Okay, 3/4 arc length and area of a sector. You have done arc length, yes?
Yes.
Okay, we're going to add area of a sector to it. Arc length, we have S equals R theta. What does S stand for?
Sector.
Well, it stands for sector length. Which is also arc length. Okay, what is a sector, guys?
Part of a circle.
A what?
A cut of a circle.
Well, it is. It's a part of the circle, but it's a specific part of the circle. It's
The top.
It's from the center of the circle, cut by 2
It's the section between
radius. So this is the sector right here. But now I have a question for you. That is a sector, right? What about this? Is this a sector also?
No.
Why not? But right here, it's cut here and here. So this would be, we could call this S1, but this whole thing from here to here, this all here, is also a sector.
Oh.
Because you've cut part of a circle. Now, is this a sector? No, that's a circle. Because I didn't cut it up. Got it?
Yep.
So is there any limit to the number of sectors I can make in a circle? No. Just like there's no limit to the number of cuts I can make in an actual line, right? Okay, what is R? Radius. What is theta? It's the angle in what? Nope. Radians. Must be in radians. If it is not in radians, then you have to put it in radians. And how do you put something in radians? Degrees to radians, you multiply by what?
It's either pi over 180 or...
Well, think about what you want to reduce out. You want to get rid of the degree, so it has to be in the denominator, right?
So
Pi over 180. Now, just because it doesn't have a pi in it doesn't mean it's not in radians. Because they'll say the angle is 3. And it'll be 3 radians, okay? Sometimes the pi's are multiplied out or whatever. Okay, so we're going to use that. So I'm not going to do much with that because you already know how to do it. So all these problems you should be able to do today, right?
Yes.
Okay, given that give the length of an arc cut off by a central angle of 2 radians in a circle of a radius 4.3 inches. So the first thing you need to just do is make a what? Picture. What's your picture look like?
A circle.
A circle? And a sector. Yes?
Yes.
Now, could have also just done this. Yep, either one. Okay, so it told me that the central angle is 2 radians. So where's that? Right there. So that's 2. That's 2. And it says that the radius is 4.3 inches. So 4.3 inches and 4.3 inches. So what am I looking for? S, R, or theta? S. Can I move this around to make it R?
Yeah.
What's R?
Radius.
Yeah, but what is it equal?
R equals S over theta. 4.3.
It'd be S over theta.
Yeah.
Okay, what would theta equal?
Theta equals S over
S over R. All you need to know is one of those and you can move it around, right?
Yes.
This is the one that I always go to, usually, because it's multiplication. But does it matter which one you remember? Nope, you just got to remember one because I ain't giving it to you. So we're doing S. So S equals R theta. I would advise you to write that every time so you remember. Okay, R has to be in what? Is it? Yes. So we have 2. Oh, theta has to be in radians, not R. R is 4.3 and theta is 2. So what is S? 8.6 what? Inches. Make sure you know what unit you're putting it on there, right? Radius and sector length are going to get inches. Angle is going to get not a degree because it's going to be in radians, right?
Yeah.
So do we have to write anything?
No.
No. Okay, so we're going to have some those things. Ferris wheels. Yep. There's so many Ferris wheel problems, guys. They put a Ferris wheel thing on there every time. Your Ferris wheel just needs to look something basic. Just like that. Can't float in the air. There's your Ferris wheel. Okay? And they say P sub 0. Remember that's position at 0 time, right? And P sub 1. That's position at first time. And my central angle would be here. If these two anchor lines bother you, could you get rid of them?
Yes.
Yes. Okay. It says figure 3, that's figure 3, is a model of George Ferris's Ferris wheel. Recall that the diameter of the wheel was 250 feet. So D equals 250 feet. Write down information. And theta is the central angle formed by the rider who travels in his or her from P1 to P2, or P0 to P1, or P1 to P2, or P6 to P8, or whatever, right? Doesn't matter. Find the distance traveled by the rider if theta equals 45 degrees and theta equals 105 degrees. So it wants to know the distance traveled. So what are we finding? S, theta, or R? S. We're finding this right here. Here's our picture. So what is our R? 125. So we're going to put it 125. And we have our thetas. We have two different thetas, yes?
Yes.
So we're going to use S equals R theta. Can I say theta R too?
Yep.
I usually write S equals R theta, but when I write it out, I put theta R just because I do. Okay, what do I need to do first?
Degrees to radians.
Degrees to radians. 45, no calculation. 45 is what? Pi over what? Pi over 4. Because 4 goes into 180 how many times?
4.
4. Okay. Now, 105 is not an angle we know, is it? No. So we need to multiply it by what? Pi over 180. And I probably should reduce, yes. What goes in both 105 and 180? 5. So this would be 21. And this would be 35. Right? 36, thank you. Can I reduce it now? Oh, my degree's reduced. Can I reduce it more? 3. So I get 7 and 12. So theta here is 7 pi over 12. And so I just throw it in here, right?
Yep.
So S equals 125 pi over 4. What's my label?
Radians. Feet.
Feet. I'm finding a sector, not finding an angle. Now, I just wrote it like that. What do I need to do if I can?
Reduce.
Can I reduce that?
No.
Okay. Then, what's my position at 105 degrees? So that would be 125 times 7 pi over 12. Can I reduce 125 and 12?
No.
No, because the only thing would be 3, if anything, right? And 1 plus 2 plus 5 is 8, and 3 doesn't go into 8. So I have to take 7 times 125. So 7 times 5.
Or 35.
So 5, carry a 3. 7 times 2
14.
plus 3.
17.
17, carry a 1. 7 times 1 plus 1 is 8. Pi over 12 feet. Now, since I tried to reduce before, is this going to reduce? No. That's why we reduce first, because I don't want to reduce 875 by 12. Do you?
Nope.
No. Was it that bad? Write down information. Make yourself a lousy picture. You all can draw as good as me. I know you can. Okay. So, the minute hand on the clock is 1.2 centimeters long. So I probably should draw a what? Clock. And the minute hand, is it the long one or the short one? The long one. So that's the what of the clock? The radius. So the radius is 1.2, right? To 2 significant digits, so it's going to say throw it in a calculator when we're done, but I don't care about that, right? How far does the tip of the minute hand travel in 20 minutes? Okay. So I drew my picture like that. Is that 20 minutes?
Yeah.
That's 15 minutes, right? So 20 minutes we'd be where? Like down here?
Yeah.
Okay. So we're looking for, I need 2 different colors. We were looking for this right here, aren't we? So we want to know how far, so that's S, isn't it? So I need S equals R theta, and I have R, it's 1.2, yes? We're finishing this. Okay, we need to figure out theta. Now we've talked about this. You've had problems like this. How far is every 15 minutes? What angle is every 15 minutes? 30. Yes?
Yes.
So this is 1 more than 90. So this is 9, like, let me go backwards. This is, if this is 0, this would be 180. Yes?
Yes.
Or pi. Got it? Or you can think of this. What's the radian for 30? Pi over what? 6. And this would be 2 pi over 6. And this would be 3 pi over 6. And this would be?
4 pi over 6.
So that would reduce to 2 pi over 3. Because if it's here, this is 60, yes?
Yes.
So 60 in the second quadrant would be what? 2 pi over 3. So there's different ways I can think about this problem, correct? The more you do them, is it the easier it's going to get? Yes. So 2 pi over 3. Well, I don't have a calculator right at the second, so 2.2 by 2 is 2.4 pi over 3. Yes? And I shouldn't leave a decimal in a problem, should I? In a fraction?
No.
How do I get rid of 0.4? I multiply by, and if I multiply the top by 10, I have to multiply the,
Bottom by 10.
so that gives me 24 over 30. Now can I reduce that?
Yeah.
By what?
6.
6. So it gives me 4 pi over 5 inches. because we're looking for S, right?
Yes.
And then I put that in my calculator. So anything to do with sector length, you should be trying. Got it?
Yep.
There are problems we didn't get to, obviously, but you're making what shape? Everything is what shape today? A sector. We will finish notes, answer questions. Probably tomorrow we'll finish notes first and then